Our third unit together deals with transformations, and our first lesson is going to focus on reflections, taking an image and reflecting it over a vertical line, a horizontal line, a diagonal line. We're going to be working in the coordinate plane, so graph paper is required. Pause the video, go out and get your graph paper if you haven't gotten that yet. Required class material, let you know about that in August, and now we're finally getting to use it. We'll use it here and we'll use it in Unit 7. The goal is to draw and describe the reflection of a figure across or over a line of reflection. And to begin, we're going to talk about rigid motions, all right? The focus of this unit is to do only rigid motions. Basically what that means is that when we move this figure, it doesn't change the way it looks. It just maybe changes its orientation. Maybe it's been rotated, but it's still a congruent figure. It's still the same size, it's still the same shape, all the angles are the same measure, all the sides, all the segments are going to remain the same length. They're not going to be changing when we move the figure, all right? Or when we reflect it, when we translate it, when we rotate it, or do any combination therein. So a rigid motion maintains the size and shape of the figure. We will do dilations in second semester, but for right now, we're going to talk about, do we understand what rigid motions are? So the way that these are always broken down is there is a pre-image before we do the transformation, and then there's an image after we do the transformation. So like I said, our focus is on rigid motions, which means it maintains the same side and same shape. This is a rigid motion. If I could spell motion. All right? This figure maintains its size and shape. This segment is the same as that segment. This one is the same as that one. This angle here is going to be congruent to that angle there. They're not changing they're not changing the size or the shape. Whereas on this one, obviously you can tell that even though this angle here may be the same as that angle there, we know that this segment and that segment are not congruent. So this is not a rigid motion. This is just a straight identification. Do we understand the vocabulary? Draw both of those shapes, relatively the same size, do your best work to say that this is a rigid motion. Draw both of those shapes. This one's slightly larger, so you can tell, hey, this is not a rigid motion. Understanding that vocabulary is critical for our work in this unit. It also helps you vet and verify that when you draw your image, after given a pre-image, that it's the same size and shape, right? If the picture looks different, then you know that you didn't do it correctly. But in order to do that, you need to understand what a rigid motion is. A lot of information here, a lot of word vomit. Get it all down, draw the picture as well. So what we're going to do is we're going to be taking this image that's drawn, triangle ABC that's drawn here in black, and we're going to be reflecting it over a line. Sometimes we call it line M. A lot of times, since we're working in the coordinate plane, line M will have an equation. We're going to reflect it over the vertical line, x equals 3, or reflect it over the horizontal line, y equals -2. Or we're going to reflect it over a line that's not horizontal or vertical. Maybe we're going to reflect it over the line y equals x and move from there. But a reflection basically is a rigid motion, a transformation that reflects each point across the line of reflection. All right, so there's some key pieces here that you want to make sure that you get. All right, I know that this is a lot of explanation, a lot of information, but we're going to try to digest this bit by bit. A reflection has these properties. If a point is on line M, then its image is on the same point. So here A and A prime is how we say that. We say that A prime, all right, is going to be on the same point. But if point B is not on line M, see how point B is not on the reflection over line M, then that means that B prime is going to be located at a spot that is along a line that is perpendicular to and bisected by line M, all right? So there's a lot that's happening there, all right? The perpendicular bisector, perpendicular to and bisected by line M. So we have this line segment that's drawn and dashed that I just erased right here, B and B prime, right? Here's B, there's B prime. But those are equidistant from the line of reflection and perpendicular to, they are on the line that's perpendicular to that line of reflection. So line B isn't just drawn vertically, all right, or line B, B prime isn't just like, oh, I'm just going to draw it over here. Here's where B prime is. It's not, you don't just draw it vertically or horizontally or whatever. You draw that segment perpendicular to that line of reflection, and then you copy it onto the other side, having the same length, the same distance away, equidistant from that line of reflection. All right, so there's a lot happening here. The reflection of triangle ABC across this line can be written as the capital R reflection over line M, sometimes that will have an equation like x equals 5 or y equals x or whatever else, of parentheses triangle ABC is equal to triangle A prime, B prime, C prime. We want to use this particular notation so that we can communicate effectively about what we're doing and what we're talking about. This is hard to learn and do well, so just make sure that we do that well, right? Ask questions as you have them, get feedback as necessary. But we want to make sure that we are performing this rigid motion so that the lengths of these segments are the same, right? This line and that line are the same, right? AC and A prime C prime are going to have the same length. The angle that's formed between angle BAC is going to be the same as the angle that's formed between B prime, A prime, and C prime. It's the same angle. It's going to be congruent, all right? And so we want to make sure that we maintain those measures. We're going to be not measuring these segments traditionally. We're going to be trusting that if we did our work correctly, our construction correctly, that we have maintained that measure. So we're going to practice that. We're going to reflect this triangle across line L. Your drawing is going to be fundamentally different than mine because you're going to try your best to draw this triangle and you're going to be drawing this line L. This will require that you use a ruler. You need to be able to measure what we are drawing. I'm actually going to use one that has centimeters so that we can measure a little bit more accurately than the inches. And so we're going to do our best. So again, the goal here is that we want to draw our segments that are from the vertices of this triangle that are going to be perpendicular to line L. We can label those intersections if we want, but how do we make sure that we draw our segments perpendicular? Well, the way that we do that is, again, whichever side of your ruler you want to use, you want to make sure that the segments, the dashed line that you drew, is going to go through the hash marks on your ruler. If you do that, then you'll be able to see and verify that you have drawn a segment that is perpendicular to that line of reflection. All right? Now, each of these segments, if these segments are all perpendicular to the same line, then we know that that means that those segments are going to be parallel to each other. All right? So if you've drawn these, and you can say that these are right angles, these are right angles, these are right angles, then you know that these lines should be parallel to each other. That's huge. That's a good kind of spot check to make sure that you drew these segments parallel to each other, perpendicular to that line over which you are reflecting. Now, you can label those intersections if you want to. You can call this point A, B, and C if you want to. It is not necessary, but it's important to note that that this ought to be perpendicular to that each of those line segments ought to be perpendicular to the line of reflection. Next, what we want to do is double those segments. So we want to take this length that's going to require us to measure and draw it over here. This length and draw it over there. Again, continuing through line L and perpendicular to line L so that we can see where point G prime, H prime, and F prime are going to be. So we're going to measure those to the best of our ability. All right, I'm using centimeters, so my numbers are going to be different than yours. But this one is, in my humble opinion, 10, 20, 4 and a half, 20, 1, 2, 3, 4, 24 and a half centimeters. So now I have to measure 24 and a half centimeters. There's 10, there's 20, there's 4.5. So I'm measuring this, and I'm going to call that point F prime. All right, over here, I am going about 9, just under 9, so 9.75 centimeters. So I'm going to go 9.75-ish centimeters. It's not perfect, but we're going to do our best. That's where H prime is located. And then finally, for G prime, We're going to connect that. I'm going to count this as 10, 15, 16. This is, well, 16 and maybe a half. So we're going to do that again. There's 10, there's 6, and then like a half-ish. This is where G prime is. All right, now those, you can make those dashed boundaries if you want to, or dashed line segments if you'd like to. That's not required, but maybe it's helpful. But now we are going to connect, I thought that those instructions were going to be here. Now we are going to connect those dots. Now when we do that, we're using our ruler again, our straight edge, so that we can do a very, very good job. We want to do our best work there. We should see that the triangle G prime, H prime, F prime is a congruent triangle. It has the same dimensions. Sometimes it's helpful to maybe measure these out. We can see how poorly a job Mr. Hibbett did here. I measure that out, I get about 10 centimeters. What do I have here? Oh, about 10 centimeters. Okay, it matches. They measure the same because I did a decent job of this. It's not going to be perfect. It's not going to be a work of art. Let me show you what it looks like. Don't erase these lines on your paper unless you're willing to redraw them, but I'm going to erase those lines so that we can see that this image, this pre-image, was reflected to make this image, or this image is a reflection of our pre-image. These are equidistant from line L. These points are equidistant from line L. These points are equidistant from line L. All right? And so that construction takes time. It's not impossible to do. It just takes time to do it. And it's going to require that you use a ruler. And generally speaking, it's going to be requiring that we're using graph paper. All right, speaking of graph paper, make sure that you have yours. If you haven't gotten it yet, you need it for this. All right, sketching this is not going to suffice because you're going to do a very poor job. We have these points, A, B, C, and D. So let's go ahead and plot those dots. We know how to plot dots. We learned about that in Algebra 1. We've got A prime. We've got, I'm sorry, this is A. We've got B, which is 2, 4. We've got C, which is 4, 2. And then we have D, that is -2, 0. So again, plot those dots to the best of your ability. We are going to use our ruler to connect the dots. I know it seems a little bit silly to have to use our ruler for that, but the better we do with our drawings, the better we will do with our reflections. All right, now we are going to reflect this over the x-axis. So we know where the x-axis is. This is the line y equals 0 is also called the x-axis. All right, those are the same thing. Oh, excuse the bell there. And so we are going to reflect this over the x-axis, which means that D prime is going to be in the same location. A prime was 3 points above, and now it's going to be 3 points below. B was 4 points above, so B prime is going to be 4 points below. C is 2 points above, and so C is going to be, or C prime is going to be 2 points below. A key concept here is to recognize that if you're reflecting over the x-axis, which is the same as reflecting over the line y equals 0, if you reflect, all that you're changing is the y value. If it's a positive number, it's now going to be negative. If it's negative, it's now going to be positive. When we do that, we can connect the dots again, use our ruler, and we should be able to tell, again, if we're using our graph paper as we're instructed, if we're using a ruler as we're instructed, we should be able to recognize that our new drawing is a reflection of the original, that it is congruent to the original. It has the same side lengths, it has the same angle measures. When we do the same thing but reflect it over the y-axis, I'm going to do this one in blue, reflect it over the y-axis, what we're going to do with our reflection over the y-axis is we are simply going to change the x values. All right, the y-axis again is the vertical line that is an x equals 0. And so I'm going to do this one in blue if that's okay. Our A prime is going to be in the same place. B is 2 spaces away, so we're going to go 2 spaces to the left. C is 4 spaces away, so we're going to go 4 spaces to the left. D is 2 spaces away, but we're gonna go 2 spaces on the other side, all right? So we're moving this is on the left side. I've got to move it now to the right side. It's not I'm not moving it horizontally. I'm reflecting it, all right? And so that ability to visualize this concept of reflection is critical. I didn't use my ruler there because I want to speed this along a little bit. But we should notice that from the black one to the blue one, we are simply taking one and reflecting it over that axis. It does reflect over itself, onto itself, and that's okay. We're allowed to do that. But you're going to notice that it is reflected like a mirror reflects, all right? So reflection is just about drawing that image given the pre-image. If you've got questions on that, please make note of that right now. It's really important for 3A that you can handle that. This is again information that I discussed on the last slide, but if you're reflecting across the x-axis versus the y-axis, this is how that changes. So pause that if you need to write all that information down. Most of that we had on the last slide, but this is a kind of a P to P prime transformation if you want to write that as well. All right, so this is the hard part, all right? So I want you to put a little note that this is maybe tough. All right, that might be tough for you to describe the reflection. This requires that you have a good idea and understanding of how to write the equation of a line, how to find a midpoint of a line segment, how to write the equation for horizontal and vertical versus when you have to use the point slope formula. All right, so there's a lot that might happen here that could be a struggle for you if your Algebra 1 is weak. So make a little note that this may be tough for you. And make sure that you mark all those steps. I'm a big fan of steps. I'm a big fan of process because if you can follow the process, then you'll ace it every time. The problem with steps is that a lot of us struggle sometimes to follow directions or remember what the steps are. And so having a good explanation here is, I think, very, very useful, but then referencing that explanation while you do your work in class will help you learn what those steps are. So have that information down, and we are going to do this process as best we can. So I've got K and K prime, L and L prime, M and M prime. We're going to give, this is the pre-image, and I can tell that because it's just K, L, and M. This is the image after we reflect, and I can tell because it's K prime, L prime, M prime. We're going to find the line of reflection, and then hopefully we're going to write the rule. All right, writing the rule is one of the toughest things that we are going to be able to do in this unit. And so obviously you get lots of practice with that. So -3,5 is K, 1,3 is L, and -5,1 is M. So this is our original triangle, KLM. And then our next one is K prime, L prime, M prime. And so we're going to see how this is reflected. I'm going to draw this one in red. 5, -3, 3, 1, and 1, -5. This is L prime, K prime, and M prime. All right, and now we can probably tell already, just guesstimating, where we think that line of reflection is going to be. But again, writing the equation of that line is what we practiced at length in our last unit. If we have 2 points, then we can find the slope. If we have the slope and a point, then we can write the equation. And so what we're going to find here is, if I use my blue marker here, and again, if you're color coding with your own pen, that's a good idea. You're working on graph paper, right, guys? We've got this connection here. We've got that connection there. And we've got that connection there. So with each of these, what we want to do is find out where the midpoint of these are. Now you can find the midpoint of L prime using the midpoint formula. You can also find the midpoint of K prime using the midpoint formula, of M prime using the midpoint formula. So again, you find the midpoint by using the average. You can't see that blue marker very well. Sorry, guys. By taking the average of the x's and the average of the y's. Now, in a lot of cases, you might have to do all of that work. But in this case, if we're using graph paper, we can tell exactly where that midpoint is going to be. All right? We can tell where that midpoint is. right? These are the same length. These are the same length. These are the same length, and we can tell where that is. If you're having trouble finding that, then you get to use the midpoint formula. But if we have 2 points, I've got 3, if we have 2 points, then we can draw the line that is going to be our line of reflection. I'd love to do that in a different color. I have one other color, but it's a light blue. Someone left this in my classroom, so I'll just use that. Let's see how that goes. Whoops. All right, so there is our line of reflection. So if we're going to write the equation of this line, then we need to have 2 x comma y's, so we can find out what the m is, or we can count rise over run. I'm going to do a little spoiler alert here and say that the slope is going to be 1. So if I have this point, which is 2, 2, so let's do 2 and 2, and this point is 1, 1. I'm going to get 1 over 1, which is 1. So the slope is 1, but then I've got to use my point slope formula to find the equation of the line and find out that it is y equals x. All right? So the equation of that line is y equals x. Now bonus points here, because if we can do this today, and if we can say that the reflection over the line y equals x of triangle KLM is triangle K prime L prime M prime, then we have done an amazing job. This writing of the rule, not just finding the line of reflection, but writing the rule is very challenging because it's new. You're writing a new notation, all right? The good news is that you're given the original triangle. You know what the new triangle is, right? It's just the primes, right? And if you know you're doing a reflection, then you're writing a capital R. The tough part might be for you finding that actual line of reflection, all right? You might need to use the midpoint formula to do that. You might need to use the slope formula to find the slope. You might need to use the point slope formula to find that. But if you can look at this line and say, oh, the slope is 1 over 1, slope is 1, and the b value is 0 because it goes to the origin, then y equals 1 times x plus 0, that's just y equals x. If you can do all that without having to do all that work in this kind of green-blue, then that saves you time. All right, this was a lengthy one. Oh, hey, ask yourself this question. Do you like that format? Or does that not pop as much? Here, our work pops a little bit here, maybe it doesn't. I don't know, give me some feedback on that. Sorry for the long video. All right, so on this, what I would like for you to make sure that you do is that you communicate to me if there's any part of this that went too fast. If there was a part that went too fast, then maybe replay it, right? You have that power, that capacity, and so make that happen. But I want to make sure that you feel comfortable and confident with bringing a ruler to class, having graph paper for those notes, and being able to find your lines of reflection, writing their equations like we did in Algebra 1 and like we did in Unit 2.